Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. Okay, my name is Ameer Hakim bin Muhammad SUMAIRI with MATRIK card number B07171710886. I want to present about the effect of E7018 filler metal on microstructure, mechanical properties and corrosion behavior of low carbon steel that are produced by SMAW process. Okay, I was supervised by Dr. Muhammad FAUZI bin MAMAT. Okay, my first point is introduction. Okay, welding is the process of joining two plastic or metal parts by melting them with or without using a further molten material. Corrosion is a natural process that converts a refined metal into a more chemically stable form such as oxide, hydroxide or sulfide. It is gradual destruction of material by chemical and or electrochemical reaction with their environment. Okay, corrosion happens primarily in metal. Corrosion will contribute to financial and life injuries. This is possible and continuous process, but controllable. Controlling corrosion make metal has longer lifespan. Okay, problem statement. Metal degradation due to the unsuitable welding parameter. My second point is low carbon steel oxidization for over period of time. My third point is the pace of advancement of the corrosion cycle depends on a variety of variables, but mostly on the microclimate that surround the system. Objective of research. My first point is to investigate the mechanical properties of low carbon steel welded metal using SMAW process with E7018 filler metal. My second point is to perform the non-destructive test on the filler metal welded parts. Okay, my last point is to study the corrosion activity in 3.5% sodium chloride and distilled water solution in the welded low carbon steel. Okay, scope of research. This project using E7018 filler metal to analyze the effect of the welded metal low carbon steel on microstructure, mechanical and corrosion properties. Okay, my next point is the type of additive that are used in this research is liquid penetrant inspection. Okay, third point is I using the water jet machine to cut the material I use into the size of 10 mm in width times 10 mm in height and also times 50 mm of length. Okay, last point is to focus corrosion behavior of welded metal low carbon steel with E7018 filler metal in 4 parameters, which is week 1, week 2, week 4 and also week 5 with 2 solutions which are distilled water and also 3.5% of sodium chloride solution. Okay, literature review. Okay, welding is the process of joining two plastic or metal parts by melting them with or without using a further molten material. The heat produced by an arc is used in welding to melt metal rods, which solidify to provide a strong joint between the metal surface. Welded metal. Welded metal is the material that has melted and resolidified as a result of welding operation. In cases where no filler metal is added, resistant, electron beam, laser and some autogenous arc welding, the weld metal has the same composition as the parent material. Okay, my next point is base material. I use low carbon steel has a low carbon to iron ratio. Low carbon steel is by definition less than 0.3%. Often, as a mild steel processing costs less than medium and high carbon steel. In addition, low cost of carbon steel, its efficiency in some application can be increased while its performance application decrease. Okay, filler metal. I'm using a E7018 electrode, which is E electrode 7 minimum tensile strength, 0 well position flat horizontal, and lastly is 18, which is type of coating and current. Okay, my next point is corrosion. Corrosion is the process of degradation of metal properties through an unwanted substance. Okay, next, chemical or electrochemical attack by its environment. This is the example of form of corrosion. First, uniform corrosion. Next is splitting corrosion, stress cracking corrosion, crevice corrosion, intergranular corrosion, and lastly is galvanic corrosion. Okay, research methodology. Okay, flowchart of the project. Specimen preparation of the welding process. My base material is low carbon steel and filler metal E7018. I use diffusion welding, which is a small process, shielded metal arc welding. Then by using design butt joint. Okay, first I perform the non-destructive test, which is liquid penetrant inspection. Then I go to the corrosion test by using the immersion test. In the immersion test, I use two various of solution, which is distilled water and also 3.5% of sodium chloride. Then I analyze the result of the experiment by checking the visual inspection and etc. Okay, in mechanical test, which is micro hardness and microstructure. In micro hardness, I use the Rockwell hardness. Then in microstructure, I use the inverted research microscope as my microscope. Okay, next is thesis. Okay, first, I want to talk about the raw material. I'm using low carbon steel as my raw material, which is 50 mm in length, 10 mm in width, times 10 mm in height. Okay, next, I perform the non-destructive test, which is liquid penetrant inspection. Then I go to the cutting process, which is water jet machine. Then I go to the microstructure and micro hardness testing. In microstructure, I use the inverted research microscope with 1000 magnification. Then micro hardness testing, I use the Rockwell hardness. Okay, and lastly, I go to the SEM and EDX analysis. SEM is scanning electron microscope. EDX is energy dispersive X-ray. I go to the microstructure analysis and the element distribution. Okay, materials. Low carbon steel. Okay, next is the corrosion test. Okay, sample preparation. Before that, I apply the silicon sealant on the non-profile surface on the part that I don't want to use. Okay, next emission test. A with distilled water. B is immersed with 3.5% of sodium chloride. Okay, emission test according to ASTM G31. My result can be obtained in 7, 14, 28 and 42 days. I use the medium, which is a 3.5% of sodium chloride solution and also distilled water solution. Okay, result and discussion. Okay, this is the structure of the welded joint, which has well metal deposited, weld joint, SEM and EDS, base metal, low carbon steel, and also micro hardness and microstructure. Okay, microstructural analysis. Okay, before I perform the microstructure analysis by using inverted research microscope, I need to etching my sample by using premix nitro solution. Okay, from that we can see that the ferrite and pearlite will occur at the base metal. Okay, pearlite is the darker area, then the ferrite is the brighter area. Element distribution. There are four element distribution, which is carbon, oxygen, silicon and also ferrum. They has their own color, which is red, blue, green, and also dark red. Okay, next point is micro-hardness result. According to the figure above, the graph shows that the top part sample has a higher value compared to the bottom part. This is because the top part receive more heat compared to the bottom part during the welding process. When the part are more exposed to heat, the more softened it will be. The figure shows the HSG has a high micro-hardness value to the carbon from the weld metal transfer from the weld metal to HSG during the welding process. Okay, my next point is emission test, which is visual inspection. I used two various of solution, which is DC water and also 3.5% of sodium chloride. Okay, that table show the sample immersed into solution. When it immersed to the sodium chloride solution, compared to distilled water solution, some thicker sample iron oxide has accelerated the low carbon steel to rust, as electrons travel more readily in sodium chloride than water. These findings are close to the previous visual inspection corrosion research. The development various corrosion from such as galvanic, crevice, and corrosion exfoliate is seen. A visual inspection clearly shows the reddish brown product. My next point is weight loss measurement. Okay, from the figure above, we know that the weight loss of the sample is higher when it immersed in the 3.5% of sodium chloride solution compared to when it immersed with distilled water solution. Okay, next is corrosion rate. From the figure above, we know that when immersed in the 3.5 solution of sodium chloride, the corrosion rate of the sample is higher than when it immersed in distilled water solution. The conclusion is the longer the sample weight loss in a short period of time, the greater the rate of the corrosion. Okay, this is microstructure observation. I use two types, which is SAM, scanning electron microscope, and also EDX, energy dispersive X-ray. Okay, next is the result scanning electron microscope. From the base metal, you can see that the uniform corrosion happened in the sample 1 after 1 week. Okay, uniform corrosion happened because the environment, which is oxygen. Okay, next is we know that corrosion happened in sample 1. In sample 3, we know that crack happened. Crack happened will occur during the welding process. Okay, from the weld metal, we can see that the pitting corrosion happened. The pitting corrosion happened because it contains aggressive chemical species such as chloride. Chloride is particularly damaging to the passive film, which is oxide, so pitting corrosion can initiate at the oxide breaks. Okay, this is the result of scanning electron microscope for 3.5% of sodium chloride solution. We know that sample 1 has uniform corrosion, though the sample 4 has the pitting corrosion. In HSG, we know that uniform corrosion happen and also pitting corrosion. Matter uniform and pitting corrosion also happen. Okay, this is a result energy dispersive spectroscopy for the distilled water solution. They have 4 elements, which is carbon, oxygen, silicon, and also ferrum. Okay, this one also 4 type of element, carbon, oxygen, sodium, and also ferrum in immersed with the 3.5% of sodium chloride solution. Okay, next is conclusion and recommendation. Okay, there are three main zones, which is base metal, HSG, and also weld area. Okay, next, the presence of pearlite and ferrite. There are 4 elements existed, such as iron, oxygen, sodium, chlorine, and also silicon. Okay, the result of micro-hardness confirm that the top line surface of the sample has low micro-hardness value compared to the bottom part. Okay, from the emission test result, we can see that the corrosion occur on the 3 main zones, which is HSG, base metal, and also welded area, through visual inspection, weight loss measurement, corrosion rate, and also scanning electron microstructure, which is SAM. Okay, next is weight loss occur after the sample is immersed in distilled water solution and 3.5% of sodium chloride. Corrosion that occurs in sodium chloride solution is worse compared to the sample immersed in the distilled water solution. Okay, my next point is the longer the sample loss of weight in a short period, the higher of the corrosion rate. The corrosion rate was determined by the sample weight loss. The corrosion rate is determined by millimeter unit per year. Next, uniform corrosion will mostly occur in SAM. And last point is from the energy dispersal X-ray, the element distribution contained on the sample that already immersed in 4 parameters, which is week 1, week 2, week 4, and also week 5. Okay, last is recommendation. First, the sample surface must be carefully taken so that no other material may be added to the surface. To stop, for example, touching the sample surface whether or not with a bare hand. Second point is store the sample in a silica gel pack vacuum container after the sample have been extracted from the immersion case. My third point is the time taken of immersion test of the sample should be longer to get the better result and clear results such as 8 week to 16 week of immersion. Okay, my last point is use EDM wire cut because there is only a small amount of heat applied to the sample and it does not interfere with the microstructure. Okay, this is my reference. This is my Gantt chart. Dr. Omar Bukuti and also Dr. Lakoti for your attention. I hope that you all can give me the best mark. Thank you.